Again, welcome to Mathematics 164. In this lectures, we're going to discuss integral exponents. That's the properties of exponents. So here, for example, when we say a to the power n, we mean we are going to multiply a n times. And normally the n will be called the exponent and the a will be called the base. So for example, we have 4 times a to the power n. This means we are going to multiply a 4 times. Then the answer we get will multiply by 4. So normally we are going to call the 4 the coefficient of a to the power n. For example, here we have -3 to the power 4. Now the exponent 4 doesn't affect the negative. So it only affected the 3. So it will be 3 times 3 times 3, which will give us 81, and also the negative. Now, if we have a parenthesis, open and close, and we have -3, this means the exponent 4 affects the negative and 3. So anytime we have an exponent even number and we have a negative, the answer becomes positive, because we know negative times negative is positive. And negative times negative is positive times another negative become negative times another negative become positive. So anytime that we have a negative value and the exponent is even number, the answer will be positive. Now, if the exponent is a odd number, the answer will be negative. So -3 all square all to the power 4 will be positive 81. But negative, then 3 to the power 4 will be negative 81. So these are some of the properties. So let's go through the multiplication property first. So here, if we have a to the power m times a to the power n, now the base are the same, a and a. In this case, we are going to add the exponent. So the answer will be a to the power m plus n. Now, with division, if we have a to the power m divided by a to the power n, if a is not equal to 0, then we're going to say that we are going to subtract the exponent of the denominator from the numerator exponent. So the answer will be a to the power m minus n. That's if m is greater than n. Now, if m is the same as n, then we get 1, because we are going to get a to the power 0, and any value or variable raised to the power 0, the answer is 1. Now, if n is greater than m, then we are going to get a negative exponent value. So here we can find again the reciprocal of it. So it will be 1 over a n minus m to make it positive. Now, if we have a times b all raised to the power n, is the same as writing a to the power m times b to the power n. And if we have a divided by b all raised to the power n, is the same as a to the power m divided by b to the power n. Now, a to the power m to the power n means we are going to multiply the exponents. So it will be a m times n. So now let's apply the properties or the rules of exponents here. So first question, we have 5 to the power 6 divided by 5 to the power 4. So this means we are going to subtract the exponent 4 from the exponent 6. So our answer will be 5 to the power 6 minus 4, which will give us 5 to the power 2, or we can write 25. Now the next question is s to the power 2 divided by s to the power 5. So this means we are going to get s to the power 2 minus 5, which will give us s minus 3. And it's same as saying 1 over s to the power 3. Or we can say, okay, 1 over x to the power 5 minus 2, which will still give us 1 over s to the power 3. Now, next question, we have x divided by y to the power 4. So this means the exponent 4 is multiplied by both x and y bases. So the answer will be s to the power 4 divided by y to the power 4. Here we have 3s squared y cubed, all to the power 4. Again, here we have parentheses open and close. So everything inside the parentheses, they are raised to the power 4. So this means 3 is raised to the power 1. So 1 times 4 will be 3 to the power 4. We have 2 and 4. So 2 times 4 will give us 8. Then 3 times 4 will give us 12. And that will be the answer here. So we get 3 to the power 4 is 81. 2 times 4 is 8. So x to the power 8. Y is 3 times 4. So y to the power 12. Next question, we have 3 to the power cube times 3 to the power 2. So the bases are 3, 3. They are the same. So we can add the exponent. So our answer will be 3 to the power 3 plus 2, which will give us 3 to the power 5. Now here we say for certain calculus operations, the use of negative exponent is necessary in order to write problems in the proper form. Now we can extend the rules for positive integer exponents to all integers by dividing a to the power 0 and a to the power negative n. So we also have the zero exponent rule. Now, as we said earlier, any base raised to the power 0, the answer is 1. So let's see example here, or our negative exponent rule first. A to the power negative n will be the reciprocal. So it's the same as writing a to the power negative 1 times n. So it will be reciprocal of a to the power n. So 1 over a to the power n. So again, a to the power negative n. To change the negative exponent to positive, we find the reciprocal of the expression here. So it will be 1 over a to the power n. Now, if I have a by b to the power negative n, it's the same as writing a divided by b to the power negative 1 raised to the power n. It's the same. So now we still have to find the reciprocal. Now, since we have a over b, reciprocal of a over b will be 1 over a over b, which will give us b over a to the power n. So that's still a reciprocal. Now, using the definition of zeros and negative exponents, enable us to extend the rules of exponents to all integers and also to express them more simply. So these are all the rules now. A to the power m times a to the power n. The base are the same, so we had exponent. Now the second one, we have a to the power m divided by a to the power n. Since it's division, we subtract the denominator exponent from the numerator exponent. So it will be a to the power m minus n. Now ab to the power m is the same as writing a to the power m times b to the power m. And also a to the power m all to the power n, we multiply the exponents. So we get a to the power m times n. Here also we have a divided by b to the power m. So this will give us a to the power m divided by b to the power m, as far as b not equal to 0. Now, any exponent of 0, the answer is always 1. So a raised to the power 0, the exponent is 0, the answer is 1. 100 raised to the power 0, the answer is 1. Now, when we have a negative exponent, we find the reciprocal of it. So a to the power negative n will be 1 over it will be 1 over a to the power n. Now, a divided by b to the power negative n will give us b over a to the power n, interchange. The numerator becomes the denominator and the denominator becomes the numerator. So let's see some examples here. So here they say we should rewrite with positive exponent. We should simplify 2 to the power 3, x to the power 4, s to the power negative 4, y to the power 5, or raised to the power negative 2. So first, if we like, we can multiply negative 2 by all the values in the parentheses. Or first of all, we can find the reciprocal of everything. So we can say 1 over 2 to the power cube, s to the power negative 4, y to the power 5, or raised to the power positive 2. So here, the first thing we decided to do, we multiply negative 2 by all the exponents in the parentheses. So we have 3 times negative 2 will give me 2 to the power negative 6. Negative 4 times negative 2 will give me positive 8. And negative 2 times 5 will give me negative 10. Then we can, if we need to change the exponent to positive, we can find the reciprocal. So 2 to the power negative 6 will give me 1 over 2 to the power 6 times x to the power 8 is already positive. Y to the power negative 10 will be 1 over y to the power 10. And here, that will be our final answer. 2 to the power 6 is 64 times y to the power 10. And the numerator, we have only x to the power 8 times 1 times 1, so give s to the power 8. Now, let's do the second question. In the second question here, we can see that s squared to the times y is raised to the power 0. So everything is 1. So we write a 2x to the power 4 times 1. And here we multiply 2 to 4, then 2 to negative 2, and 2 to y to the power 1. So we get 4 squared, then s to the power negative 4, because 2 times negative 2 is negative 4. Then 2 times 1 will give me 2, so y. Now we can find the reciprocal of s to the power negative 4, so which means it will go up since it's down. So that will give us 2 to the power 2 divided by 4 to the power 2 is 16. This 4 will go up, or we can say 4 minus 4 will give us positive 8. And y is positive square. The exponent is positive, so we leave it. So our final answer will be 2 times x to the power 8 divided by 16y squared. Then 2 can go into 16 is 8, so we get 8 in the denominator, then the 2 will be cancelled. So our answer will be x to the power 8 divided by 8 times y squared. So that will be the conclusion for these lectures. Again, these lectures, we studied the properties of exponents. So we saw the multiplication rule, division, parentheses, and etc. So again, see you in the next class. Thank you.